The vagus nerve, a bridge between mind and body. The vagus nerve, the longest cranial nerve, extends from the brainstem to the abdomen, influencing a vast array of bodily functions. Beyond its physiological role, the vagus nerve holds profound philosophical and psychological significance, highlighting the intricate interplay between mind, body, and the external world. Interconnectedness, a core principle. The vagus nerve embodies the concept of interconnectedness, a central tenet in many philosophical traditions. Eastern philosophy. Taoism emphasizes the dynamic balance of opposing forces, yin and yang. The vagus nerve, with its role in both activating and deactivating bodily systems, mirrors this principle. Practices like Qigong, aimed at cultivating qi, life force, likely modulate vagal activity, promoting harmonious energy flow. Buddhism highlights the interconnectedness of mind and body. Mindfulness practices, such as focusing on the breath, engage the vagus nerve, calming the nervous system and fostering a state of inner peace. Western philosophy. Aristotle advocated for eudaimonia, human flourishing, achieved through a balanced life, including physical and emotional well-being. The vagus nerve, by regulating stress and promoting emotional stability, plays a crucial role in this pursuit. Descartes' mind-body dualism was challenged by the vagus nerve, demonstrating the intricate and inseparable connection between mental and physical processes. Psychological dimensions. The vagus nerve profoundly influences psychological well-being. By regulating the autonomic nervous system, it shapes emotional regulation. High vagal tone is associated with reduced anxiety, improved mood, and increased emotional stability. Decision-making. A calm nervous system, facilitated by vagal activity, allows for clear and rational decision-making, free from the influence of excessive stress. Social behavior. High vagal tone correlates with enhanced social engagement, empathy, and trust, fostering deeper and more meaningful connections with others. Brain-vagus nerve interactions. Amygdala. The vagus nerve helps to regulate the amygdala, the brain's fear center, reducing anxiety and promoting a sense of calm. Prefrontal cortex. The vagus nerve enhances communication with the prefrontal cortex, improving cognitive function, emotional regulation, and decision-making. Neurotransmitter release. The vagus nerve triggers the release of calming neurotransmitters like acetylcholine and GABA, promoting relaxation and well-being. Evolutionary perspective. Stress response. The vagus nerve evolved to help manage stress responses, enabling early humans to transition from fight or flight to rest and digest states crucial for survival. Social cooperation. The vagus nerve likely played a crucial role in the evolution of pro-social behaviors, such as empathy and cooperation, essential for the survival and thriving of early human societies. Practical applications. Mind-body practices. Practices like yoga, meditation, and deep breathing exercises enhance vagal tone, promoting relaxation, reducing stress, and improving overall well-being. Therapeutic interventions. Vagus nerve stimulation, VNS. A medical therapy used to treat conditions like epilepsy and depression. Biofeedback. Techniques that help individuals learn to consciously regulate their physiological responses, including heart rate variability, which is closely linked to vagal tone. Conclusion. The vagus nerve is not merely a biological structure. It is a profound symbol of the interconnectedness of mind, body, and the world. By understanding and cultivating healthy vagal function, we can enhance our emotional resilience, improve our social connections, and cultivate a greater sense of well-being. Science behind the vagus nerve. This section delves into the biological, chemical, and physical aspects of the vagus nerve, exploring its role as a central player in maintaining homeostasis and influencing critical bodily functions. Chemistry of the vagus nerve. The vagus nerve operates as a chemical communicator, sending and receiving signals between the brain and organs via neurotransmitters and hormones. These chemical processes enable the vagus nerve to regulate vital bodily functions and maintain mental and emotional balance. Key neurotransmitters. Acetylcholine. The primary neurotransmitter of the vagus nerve, acetylcholine slows heart rate, stimulates digestion, reduces inflammation, and plays a role in attention and memory. Serotonin. Produced primarily in the gut, serotonin, influenced by the vagus nerve, impacts mood, sleep, and digestion. Dopamine. The vagus nerve stimulates dopamine release, particularly in the gut-brain axis, reinforcing the reward system and emotional resilience. Cortisol regulation. The vagus nerve helps regulate cortisol levels, dampening stress responses and promoting relaxation. Hormonal interactions. The vagus nerve interacts with the hypothalamic-pituitary-adrenal (HPA) axis, modulating the release of stress hormones like adrenaline and cortisol. Anti-inflammatory pathways. The cholinergic anti-inflammatory pathway activated by the vagus nerve reduces inflammation, playing a key role in managing chronic inflammatory diseases. Physics of the vagus nerve. The vagus nerve functions as a bioelectrical conduit, transmitting signals through electrophysiological impulses. Bioelectrical impulses. The vagus nerve relies on action potentials, rapid changes in voltage across the nerve cell membrane, to transmit information at high speeds. Ion channels, sodium and potassium. Ion channels on the nerve membrane facilitate the movement of these electrical impulses. Heart rate variability, HRV. HRV, a measure of the variability in the time interval between heartbeats, reflects vagus nerve activity. High HRV indicates better autonomic flexibility and resilience to stress. Emerging fields. Quantum biology. Exploring potential quantum processes involved in vagus nerve communication. Bioelectronic medicine. Vagus nerve stimulators use electrical impulses to enhance nerve activity, providing therapeutic benefits for epilepsy, depression, and chronic pain. Biological mechanisms of the vagus nerve. The vagus nerve's biological role spans multiple systems. Evolutionary context. The vagus nerve evolved to coordinate the body's response to threats and ensure survival, initially regulating heartbeat and digestion. Over time, it evolved functions related to social bonding and emotional regulation. Key biological functions. Cardiovascular regulation. The vagus nerve slows the heart rate, counteracting the sympathetic nervous system. Respiratory functions. It regulates breathing rate and depth. Digestive regulation. The vagus nerve enhances digestion by stimulating gastric secretions and promoting peristalsis. Immune system modulation. The vagus nerve reduces inflammation, preventing excessive immune responses. Neurobiology and brain interaction. The vagus nerve communicates with various brain regions, including the brainstem and the prefrontal cortex, influencing both mental and physical health. The gut-brain axis, mediated by the vagus nerve, connects the gut with the brain, influencing mood, appetite, and decision-making, emerging scientific applications. Vagus nerve stimulation, VNS. Clinically used for epilepsy, depression, and migraines, VNS is being explored for treating inflammatory conditions. Wearable technology. Devices like heart rate monitors help track and enhance vagus nerve activity through HRV measurements. Future possibilities. Gene therapy. Research aims to genetically enhance vagal tone to improve resilience. Nanotechnology. Potential applications include nano devices targeting vagus nerve pathways for drug delivery. Thus, the vagus nerve's intricate chemistry, physics, and biology make it a crucial player in maintaining homeostasis and influencing critical bodily functions. It serves as a conduit for bioelectrical and biochemical communication, regulating heart rate, digestion, and inflammation. Emerging fields are opening new frontiers for understanding and leveraging vagus nerve activity.